Basic concepts on logic. What is mathematical logic? It is a study of valid reasoning. It allows us to determine the validity of arguments in and out of mathematics. It provides rules and techniques to determine whether an argument is valid. So in this case, we will not deal with numbers or with equations. So again, mathematics is not all about numbers. It also deals with valid reasoning. So it can sharpen our mind, which is useful in our decision making in our daily lives. So let's start with a proposition or a statement. It is a complete declarative sentence that has a truth value, which is either true, denoted by T, or false, denoted by F, but not both. So meaning, if it is a declarative sentence, it must have only one truth value. No, it depends. So if it's true, then it's true. If it's false, then it's false. But it can never be true or false at the same time, or true and false at the same time. Say for example, today is Wednesday. So if it is really Wednesday today, then it is true. Okay, it has only one truth value. But if it is not Wednesday today, then it is false. But this statement cannot be both true and false. So meaning, this is a proposition. It is a declarative sentence with either true or false truth value. 12 is less than 7. Of course, this is a declarative sentence, but it is a false statement. Although it is a false statement, it is still a proposition. Remember, it has only one truth value, which is false. So a declarative sentence with a false truth value. Please lend me your ears. So it has no truth value at all. And of course, I think this is an imperative sentence, not a declarative sentence. So this is not a proposition. Now examples determine whether the following are propositions or not. Ouch. So I think this is not a declarative statement. It is an interjection because this is an expression. So it is not a proposition. So since this is not a declarative sentence, again, this is an interjection. All multiples of 5 are odd numbers. Okay, so we have 5, 10, 15, 20. So since we're talking about all, so it means that the whole statement is false. So it is a proposition because it is a declarative sentence, but with a false truth value. Because it says all, but not all multiples of 5 are odd numbers. We have 10, 20, and so on. So meaning this is a false statement. Although this is a false statement, since it has only one truth value, then it is a proposition. X is a real number. So in this case, we do not know what is really X because it is a variable. So it is not a proposition. Why? Because it may be true and, this is and false at the same time. Because we can substitute any number for X. It can be a complex number. So X can be equal to 1 plus 2i. Now, X is not plainly true. It is not plainly false. It can be true and false at the same time. So it is not a proposition. Because again, we do not know the exact value of X. Sketch the graph of f. Again, this is an imperative statement. This is an instruction, not a declarative sentence. 2 plus 5 is equal to 7. So this is a sentence, this is a declarative sentence, and at the same time, it is true. So it has only one truth value. Please close the door. Again, it is an imperative statement, so please. So it gives command. This is not a declarative sentence. Is it hot outside? So it is a question. So interrogative sentence. So not a declarative sentence. So it is not a proposition. The world is not flat. So it is a proposition. So it is a declarative sentence with a true truth value. X plus 1 equals 2. So the same with the previous example, x here is not given. So x can be 3, can be 4, 5, x can also be 1. So it is not a proposition because it may be true and false at the same time. So if x is equal to 1, then it is true, but otherwise it is false. Now this statement can be a proposition if we have x plus 1 equals 2, comma, if x is equal to 1. So the whole statement now is true. Okay, because we have now an exact value of x which is equal to 1. So this becomes now a proposition. So again, when we talk about proposition, it must be a declarative sentence with only one truth value, either true or false. Now we have this notation for a proposition. Some books use small letters, P, Q, R, etc. And also some books use capital letters A, B, C, and others. We have propositional connective. So it is an operation that combines two propositions to yield a new one, whose truth value depends only on the truth values of the two original propositions. So the whole truth value of these combined two propositions will depend on the individual truth values. So in reasoning, it is necessary to take into account the role of truth values in logic. So a truth value of a proposition is true if it is true and false if it is false. So say for example, Dr. Jose Rizal is the national hero of the Philippines. So the truth values is T. Zoologists study plants. So the truth value is false. Although we already applied the concept of truth value in our previous examples. So a truth table shows the relationship between the truth values of statements. This is a vital tool in determining the truth values of statements formed from simple statements. So we will encounter some truth value in the next slides. Truth value table, I mean. So let's start first with this connective negation. When we say negation, it is the opposite. Okay? So not P. So if P is true, then not P, P is false. If P is false, then not P is true. Okay, so just take the opposite. So we have this symbol. So we have this and this, or you can use the minus sign. So we have this. If we have proposition A, then the negation is just the opposite. The truth value is just an opposite. So since we only have one truth value or one proposition, so we only have one column for its negation. Next, so we have this connective and or the conjunction. So the symbol is just an inverted V. It looks like an inverted V, or you can read this maybe a hat, P hat Q. So it is true if and only if both P and Q are true. So this is the truth table. So we have proposition A and we have proposition B. Then these are all possible combinations of the truth value. So it can be both are true, both are false, then A is true, B is false, or A is false, then B is true. Okay. Now in this statement, now when we talk about and, no, the connective and, in English, it is a strict statement. Now, if you say, please bring me a paper and pen, so you must bring both of them, paper and pen, not only paper, not only pen. Okay, so in this statement, it is only, or in this connective, it is only true if both statement is true. Otherwise, it is false. So the two propositions must hold. So true, true, then true. Otherwise, it is false. Because again, when we talk about and, it is very strict. If the first statement is true, but the second statement is false, then obviously it is not true. Because again, and is strict. Both of them must have the same truth value. Say for example, 2 plus 1 is 5. And letter B, 1 foot is equivalent to 12 inches. A, what is A? A is false. Because 2 plus 1 is 3. Now, 1 foot is equivalent to 12 inches. So we have this false. So how about B? 1 foot is equivalent to 12 inches. So that is true. Okay, so meaning we will take this third row. False, true. So the overall statement of number 1 is false. Okay, so this is the overall statement. Number 2, snakes are reptiles. True. And all birds lay eggs. So snakes are reptiles. So we have these two, true, true. But we need to consider B, all birds lay eggs. So this is false. Because not all birds lay eggs. There are male eggs and other types of birds don't lay eggs. So we have this. So meaning the overall statement is false. Now let's go to disjunction. P or Q. So it looks like a V. PVQ. So it is true if and only if one of them is true. At least one of them is true. So this is the table, truth table for truth value. So if one of these statement is true, then the overall statement is true. But if both are false, then it is false. Because when we use or, it is not a strict statement or strict no word. Okay, or please bring me a pen or paper. So you can actually bring either a pen or a paper. Whereas if it is and, you must bring both. So in this case, or, so it is not that strict. So if at least one of these two statement is true, then the overall statement is true. Otherwise, it is false. Examples. 3 is even. So 3 is even, this is false. 100 is divisible by 2, and this is true. So we have false, true. So false, true. So at least one is true, so the overall statement is true. Pi has a terminating decimal, which is false. Pi doesn't stop. So this is false. 3 times 3 is 9. So it is not 6. So again, this is false. So the overall statement is this one, false. Because both of these statements are false. Again, if at least one of these two propositions is true, then it is true. Otherwise, it is false. Now let's go to conditional. It is a logical compound statement in which a statement P called the antecedent or hypothesis implies a statement Q called the consequent or conclusion. So it is written with this. So we use arrow as its symbol. And it is translated into if P, then Q. So we have this. Now let's look at the table. So if you look at this, the only false, the overall value here, the only false statement is if the second statement, the conclusion is false. If the premise is true and the conclusion is false, then it is false. Okay, so of course, if both are true, if the condition is true and the conclusion is true, then the overall statement is true. If the condition is true, but the conclusion is false, then of course the overall statement is false. Okay, now how about this 2? Whenever the hypothesis A of a conditional is false, so with these two, the last two rows, the conditional as a whole is always true. That's because if the condition is never carried out, so meaning this A is not true, it doesn't matter what the conclusion is. So say for example, if Claire buys a dog, that is A, and then B is, then I'll help her take care of it. Now, if this is false, so meaning Claire never buys a dog, then I can never break a promise to help her or take care of the dog. Okay, because there's no dog at all to take care of. So meaning the conclusion doesn't matter. So that is why in these last two columns, last two rows, it is true. So again, in this conditional statement, it is only false if true implies false. So this is the only one that is false. Conditional statement. So B, okay, so A square root of 4 is 2. So if the positive square root of 4 is 2, so say for example this is true. No, the positive square root of 4 is 2. 1 is a prime number, so this is false. So the overall statement is false. Letter number 2, I eat a lot. So if this is true, then I gain weight. Okay, so the overall statement is true. So for number 2, it depends upon the actual condition of the person reading these statements. Okay, but if I eat a lot, true, then of course we usually gain weight. So if you don't eat a lot, so usually we don't gain weight. So both of these statements are true. Okay. So related conditionals. 3 related statements, namely converse, inverse, and contrapositive. So we're given with the conditional if P then Q. The converse is just the interchange. What do you call this one? The placement of P and Q are changed. So the Q now will become the premise. The P now will become the conclusion. Okay, and while in the inverse, we'll just negate our premise or the hypothesis, and of course negate the conclusion. While in the contrapositive, it is the converse of the inverse. So this one, the converse of the inverse. So say for example, if the triangle is isosceles, then the base angles are congruent. So this is our P and this is our Q. Converse is, we need to interchange them. P implies, Q implies P. This is now P. So if the base angle, so we'll start here at the conclusion, if the base angles are congruent, then the triangle is isosceles. Okay. Now, how about the inverse? Inverse will just take the negation of the hypothesis and then imply the negation of the conclusion. So negation, what is the negation of this? Is not an isosceles. So if the triangle is not isosceles or is not an isosceles triangle, then the base angles are not. So we have here not, are not congruent. Okay? And the contrapositive is the negation of the conclusion implies the negation of the hypothesis. So let's start with the negation of the conclusion. If the base angles are not congruent, then the triangle is not isosceles. Okay, so from a conditional statement, we can have these other statements, the converse, the inverse, and the contrapositive. Biconditional. So P if and only if Q. So P implies Q and Q implies P. So meaning we have this now a double-sided arrow. Okay, if P implies Q, then also we can go back. Q also implies P. So in this statement, it is formed by combining a conditional and its converse. So this is the conditional and then the converse. So if we combine these two, it is now the biconditional statement. So dalawang condition. So the truth value of this is both are true if they have the same truth values. So you only have the first and the last row. Okay, otherwise it is false. So I gain respect if and only if I trust people. So if either one of these statement is false, then the overall statement is false. So compound proposition. A proposition formed by combining propositions using propositional connective. So say for example, we have P and Q. I like Pepsi. Q, I like Coke. So if we combine this is OR, this is the disjunction. So P or Q. So P or Q. So I like Pepsi or I like Coke. Now this is conjunction, so this is AND. So I like Pepsi and I like Coke. Okay, this is just a negation. So P is I like Coke, I like Pepsi, so I do not like Pepsi. Okay, and the negation of the other one is I do not like Coke. So if we have this, it is not the case that I like Pepsi or Coke. So this is AND. So I like Pepsi and I do not like Coke. So examples, write the following statements in symbolic form. So we have here the four propositions, H, V, R, S. So number one, today is Sunday and Harry is not happy. So today is Sunday, so we have S. And Harry is not happy, so we have H. So we have N. Okay, so this is now S, then we have the hat and H. So in symbol form, we have S, hat, H. Today is Sunday, so again S, and Harry is not going to watch a volleyball game. Now in this case, V is about volleyball game, but this is going, but here is not going. So we must negate V. So S, hat, negation of V. Number three, if it is going to rain, so it is going to rain, so R. Then, so if it is an if-then statement, so conditional, so we will use the arrow. Then Harry is not going to watch, so it is again a negation of V. So R, arrow, negation of V. Harry is going to watch a volleyball game, so it is V. If and only if, so the double-sided arrow, he is happy. So here, he is not happy. So the opposite is he is happy. So we will take the negation of H. So V, so uh, Harry is going to watch a volleyball game if and only if the negation of H, he is happy. And last, Harry is going to watch a volleyball game, so that is V, or. So this is uh, V, or. It is going to rain. So V or R. And last, convert the following symbolic statements into words. So if we have P and Q, now what is the negation of P? Gian does not play volleyball. This is P and Q. So Gian plays basketball and or while Lance plays basket. This is not basketball. The other one, this is Gian. Gian plays this. So this is Gian plays volleyball. So this is volleyball. So volleyball. So Lance plays. This is basketball. Okay, so thank you for listening.